Dear students, in this video we are going to discuss a new topic, a new chapter, rational numbers. So first of all, let us see what are rational numbers. We will have an introduction about rational numbers. Any number that can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0 is called a rational number. So it's very clear, all the rational numbers can be expressed in the form P by Q. P and Q are integers. Q must not be equal to 0. If Q is equal to 0, the division is not possible. We all know that division by 0 is not defined. Some examples for rational numbers are 2 by 3, minus 5 by 9, minus 4 by minus 7, 0, 3, minus 6. Let's understand some important facts about rational numbers. The word rational comes from the word ratio because every rational number can be expressed as a ratio between two integers. You have learned the concept of ratio. We know that ratio is a comparison between two quantities. Hence, we can write every rational number as a ratio between two integers. For example, 6 by 11 is equal to 6 is to 11, which is the ratio between integers 6 and 11. Every integer is a rational number. Every integer can be written as a rational number with the denominator 1. For example, 3 is equal to 3 by 1. Minus 5 is equal to minus 5 by 1. 0 is equal to 0 by 1. Every fraction is a rational number. You have studied fractions in the previous classes. Here we are studying that all the fractions are rational numbers. For example, 5 by 4, 6 by 7, 3 whole 1 by 2. All these are fractions and are also rational numbers. Every rational number can be expressed as a decimal. We can find out the decimal form of any rational number by dividing the numerator by its denominator. For example, 1 by 8 can be written as 0.125. 11 by 25 can be written as 0.44, etc. Once again we note that 3 by 0, minus 2 by 0, 1 by 0, etc. are not rational numbers as division by 0 is not defined. Now let's understand what are equivalent rational numbers. Two or more rational numbers are said to be equivalent if they have equal value or if they have same value. We can obtain any number of equivalent rational numbers for a given rational number. We have some methods to obtain the equivalent rational numbers. We can obtain equivalent rational numbers by multiplying both numerator and denominator of a rational number by same non-zero integer. For example, 4 by minus 5 is equal to 8 by minus 10 is equal to 12 by minus 15. these three are equivalent rational numbers. We got 8 by minus 10 by multiplying 4 by minus 5 with 2 and 4 by minus 5 with 3 we get 12 by minus 15. Now equal rational numbers. Two rational numbers are said to be equal if they have equal value. But here we have a condition to say that two rational numbers p by q and r by s are equal. That is, p by q and r by s are equal if and only if p into s is equal to q into r. That is, by doing the cross multiplication and by comparing the products, we will be able to say whether two rational numbers are equal or not. Now we are going to solve a few questions based on the topics we have studied today. The first question is, find four rational numbers equivalent to 3 by minus 7. We know that the procedure to find the rational numbers equivalent is by multiplying both numerator and denominator by same non-zero integer. Here we are free to decide the integer by which we are going to multiply. Here I am going to multiply 3 and minus 7 with 2. That is, on numerator I get 6 and on denominator we get minus 14. For the next equivalent rational number, we can multiply 3 by minus 7 with 3 on numerator and denominator. That is, 3 into 3 by minus 7 into 3 equal to 9 by minus 21. Now, by multiplying both numerator and denominator by 4, we get 3 into 4 divided by minus 7 into 4. That is equal to 12 by minus 28. For the fourth equivalent rational number, we can multiply both numerator and denominator by minus 1. So we get 3 into minus 1 by minus 7 into minus 1. That's equal to minus 3 by 7. So these are the four equivalent rational numbers: 6 by minus 14, 9 by minus 21, 12 by minus 28 and minus 3 by 7. Another question. Write the following rational numbers with positive denominator. In order to write any given rational number with a positive denominator, we have to multiply both numerator and denominator by minus 1. So here we have 4 by minus 9, that is equal to 4 into minus 1 by minus 9 into minus 1, that is minus 4 by 9. Similarly, we have minus 18 by 38 is equal to 18 by 38 by multiplying both numerator and denominator by minus 1. Remember the procedure. In order to write a rational number with a positive denominator, we have to multiply both numerator and denominator by minus 1. Another question. Which of the following pairs of rational numbers are equal? We have three questions here. First one, minus 3 by minus 7 and 15 by 35. Minus 6 by 8 and 10 by minus 15. And next question, 6 by minus 10 and minus 12 by 20. We need to check whether these three pairs of rational numbers are equal or not, or which among them are equal and which among them are not equal. We know that P by Q is equal to R by S if and only if P into S is equal to Q into R, or we do the cross multiplication here like this: minus 3 with 35 and minus 7 with 15 in the first pair of numbers. that is minus 3 into 35 is minus 105. Then minus 7 into 15 is also minus 105. Hence we have got both of these products are equal. Therefore we can say that the given two rational numbers minus 3 by minus 7 and 15 by 35 are equal. By doing the same procedure, we have seen that the second pair of numbers are not equal and the third pair of numbers are equal. Let's solve another question. Reduce the following rational numbers into its standard form. When a rational number is written in its standard form, the numerator and denominator will have no common factor. Here we have two numbers. First one minus 45 by 30 and 16 by minus 36. In the questions we can see the numerator and denominator have common factor in both the numbers, but we need to convert it into standard form so that the numerators and denominators are co-prime numbers in each rational number. Therefore, here first of all we consider first one minus 45 by 30. We find out the HCF of 45 and 30, that is minus 15. Now dividing both numerator and denominator by the HCF of these two numbers, we get minus 3 by. You can also do it by dividing both numerator and denominator by its common factors several times. In question number B, we have the HCF of 16 and 36 is 4. Dividing 16 and minus 36 by 4, we get 16 by 4 is 4, minus 36 by 4 is minus 9. Hence we have the standard form 4 by minus 9. Now we need to convert the denominator into positive, that is by multiplying both numerator and denominator by minus 1, we get minus 4 by 9. Now we are going to understand a few more simple things about rational numbers. First of all, representation of rational numbers on number line, comparison of rational numbers. We will also see how to insert rational numbers between two rational numbers. First of all, let us see how to represent rational numbers on number line. Here we have two examples. Represent 3 by 4 and minus 3 by 4 on number line. First of all, we have to draw a number line. While drawing a number line, remember that on both the sides, on both the ends, we have to place arrows, which shows that the number line does not end at both the ends. Now we can plot the points. First of all, we will plot the integers. We will plot the integers 0, 1, 2, minus 1, minus 2, etc. So here we have the plotted integers. Here we are plotting 3 by 4 and minus 3 by 4. First of all, we need to understand these rational numbers lie between which two integers. Here we know that 3 by 4 lies between 0 and 1. Hence, we need to divide the division 0 to 1 into 4 equal parts, because we have to represent 3 by 4. See the denominator is 4, and hence we have to divide the division 0 to 1 into 4 equal parts. Now the first point after 0 represents 1 by 4, second point 2 by 4, and the third point represents 3 by 4. Clearly the fourth point is 4 by 4 equal to 1, which is also a rational number. Now we know that minus 3 by 4 lies between the integers minus 1 and 0. Therefore we do the same procedure between the division 0 to minus 1, that is divide the division 0 to minus 1 into 4 equal parts. Now the first point just left to 0 is minus 1 by 4. Second point is minus 2 by 4. And the third point is minus 3 by 4. And the fourth point minus 4 by 4, that is equal to minus 1. Hence we have plotted both the rational numbers 3 by 4 and minus 3 by 4 on the number line. Now we have a question. Draw a number line and represent the following rational numbers on it. We have the numbers 3 by 8, minus 3 by 4, minus 7 by 8 and minus 17 by 8. Here the question is to plot all these rational numbers on the same number line. So first of all, we need to make the denominators of these rational numbers equal. So we know that minus 3 by 4 is equal to minus 6 by 8 by converting it into equivalent rational numbers by multiplying by 2 on both numerator and denominator. So minus 3 by 4 is minus 6 by 8. We also need to convert the improper fraction into a mixed fraction. So we have minus 17 by 8 converted into minus 2 whole 1 by 8. Now consider the first rational number, that is 3 by 8. We know that 3 by 8 is between 0 and 1. We divide the division 0 to 1 into 8 equal parts, and the third part or the third point after 0, third point right to 0 is the rational number 3 by 8. Dear students, in this number line, please note that the integer 1 is represented by the rightmost dark dot on the number line. The number 1 is slightly moved towards the left. Please understand it in the right way. Now we are going to plot minus 3 by 4. We have seen that minus 3 by 4 is equal to minus 6 by 8, which is between 0 and minus 1. So we have divided the division 0 to minus 1 into 8 equal parts, and the point which is 6th at left to 0 is minus 3 by 4 and 7th is minus 7 by 8. Similarly, we have plotted minus 2 whole 1 by 8, which is between minus 2 and minus 3. Now the next question is to compare the following rational numbers. We have two pairs of numbers. First one 5 by minus 9 and 3 by 7, and also we have minus 3 by 8 and minus 2 by 7. The first one is very easy because one number is negative and the other one is positive. We know that all the negative numbers are smaller than the positive numbers. Therefore, clearly 5 by minus 9 is smaller than 3 by 7. So we can write it like this: 5 by minus 9 less than 3 by 7, since all the negative rational numbers are smaller than the positive rational numbers. In the next question, we have two negative numbers with two different denominators. Now we need to compare them. For that, we are going to find out the LCM of denominators, and as we used to do in fractions, we are going to convert the denominator of both the rational numbers into equal, that is the LCM of both the denominators. Here LCM of 8 and 7 is 56. In order to convert minus 3 by 8 with the denominator 56, we need to multiply minus 3 and 8 by 7, that is minus 21 by 56. We also need to convert minus 2 by 7 into a rational number with the denominator 56. For that, we are going to multiply minus 2 into 8 divided by 7 into 8, that is minus 16 by 56. Now we know that minus 21 by 56 is less than minus 16 by 56. that is minus 3 by 8 less than minus 2 by 7. Now next question is to insert 5 rational numbers between two given rational numbers. The given rational numbers are minus 1 by 2 and 2 by 3. Here, in order to insert 5 rational numbers, in these two rational numbers we have different denominators. Note that in this case we have to find out the LCM of both the denominators, and we have to make both the rational numbers into rational numbers with equal denominators. That is, the equal denominators will be LCM of the given denominators, that is 2 and 3, that is equal to 6. Hence we get minus 1 by 2 is equal to minus 1 into 3 by 2 into 3, that is minus 3 by 6, and 2 by 3 is equal to 2 into 2 by 3 into 2, that is equal to 4 by 6. Hence we have got minus 3 by 6 and 4 by 6 are the given rational numbers. Now between them we can obtain the following rational numbers. They are minus 2 by 6, minus 1 by 6, 0 by 6, that is 0, 1 by 6, 2 by 6, and 3 by 6. We need only 5 rational numbers. Therefore, we can stop by writing up to 2 by 6. Hence, minus 2 by 6, minus 1 by 6, 0, 1 by 6 and 2 by 6 are rational numbers between the given rational numbers, that is minus 1 by 2 and 2 by 3. Another question. Insert 5 rational numbers between two rational numbers with equal denominators. In the previous question, we have inserted many rational numbers between two rational numbers with different denominators, in which we used to convert those rational numbers with equal denominators. Here we have two rational numbers minus 2 by 3 and minus 1 by 3, and they have equal denominators, and we can see the numerators are close by each other. The integers or the numerators which are integers are close by each other. We cannot directly find out any rational numbers between them. Therefore, we need to multiply both numerator and denominator of both the rational numbers by 5 plus 1 is equal to 6. Note that here we need to find out 5 rational numbers. Hence, we multiply both numerator and denominator of both the rational numbers by 5 plus 1, which is equal to 6. Now, minus 2 by 3, by multiplying both numerator and denominator by 6, we get minus 12 by 18. Also, minus 1 by 3, doing the similar procedure, we get minus 6 by 18. Now, we can obtain many rational numbers between these two rational numbers, that is minus 12 by 18 and minus 6 by. Hence, between minus 12 by 18 and minus 6 by 18, we have minus 11 by 18, minus 10 by 18, minus 9 by 18, minus 8 by 18, minus 7 by 18. So, we have got 5 rational numbers between minus 12 by 18 and minus 6 by 18, that is minus 2 by 3 and minus 1 by 3.